Hey, how's it going? It's good to be here. And it's actually really nice to be in the same time zone as the majority of the meetup because a lot of times, especially if you're in that European window, it's like, you know, 8 o'clock at night. And everybody else is just trying to get excited and pumped up at 9 a.m. Pacific or whatever it typically ends up being. So it's kind of nice that everybody's got that evening chill going. So I appreciate that. And for that, I actually have my coffee ready to go here. So I'm going to go ahead and share my screen here, and we'll see just what we get going out of this for tonight. I have a more unusual presentation for me. This is Data Layer Revisited. This is also learning to play in GraphQL, learning to just kind of explore and find out just what's available. So I think it'll be interesting. But the base topic here is called the data layer. And by data layer, we're referring to when you've connected these different pieces together, right? So before I get into there, let me go ahead and actually tell you who I am here, because that's probably helpful. So my name's Jesse Martin. I am a developer outreach person. I don't have a title. I have a prime directive. But I've done some stuff in the GraphQL space, been around for a little bit now in that tech, doing a lot of community content. You can find me on Twitter at MotleyDev. I am one of a few GraphQL shiny bald head people out there, but they're all good ones to follow. But when you come and see my content, you'll see that it kind of comes from sort of this explorer's perspective, or somebody who's interested in finding out what's possible, what you can do. And with that topic, the data layer as being a federated source, or as a way to connect different pieces of content together, becomes a really important concept for this imagining what's possible with GraphQL. And so when we call a data layer or federated data, we are acknowledging that the different tasks out there, the different workloads, are oftentimes handled better by different services, or even different databases, or whatever you may be trying to connect together. You might have time series data. You might have high read and low write, or high write and low read databases. But you're wanting to connect all these different data sources together to create a full picture of what your app is supposed to actually present. And so, and there's more than just the workload variances. You also have things like business or political boundaries that are getting around business inside the company. Like, you may have somebody who says, I'm not giving you access to this data that we worked so hard to get clean, and so the best you have is this decrepit old API that you have to play with, and you're trying to figure out, how do I get this into my new modern application stack? So you've got different pieces at play that are working for you, or sometimes against you, or acting as friction points behind why you have a bunch of different data sources. But the end goal is you sort of want to connect them all together. And that kind of brings me to the project that I had tonight. I had told the organizers that all of my demos always focus around beer, and I pulled a little bit of a switch on that one. So tonight there's not actually going to be any beer tasks. I've created a little demo tonight, which has been on my mind to create for a little while, and I call this self-QL. And it is connecting a bunch of different data sources for just myself, like things that I'm tracking personally on sort of a quantified self, everyday better kind of mentality, that I wanted to actually be able to eventually visualize or bring into a single API. And so, like, right now I'm doing this thing, right? I'm doing like 100 days of 100 types of things. So I'm doing 100 days of fasting, like intermittent fasting. I'm not eating for 100 days. 100 days of activity, so 100 minutes or more, 100 push-ups, writing for 100 days, 100 words for 100 days, It's like Obsidian app there, a little shout if you don't know it. So I have these different data sources, but they totally belong in different realms, right? So I could write a database that tracks all of this, and I could sort of get everything set up and make my own app for input and logging. But I have tools that do this stuff, right? I've got Fitbit that it tells me when I'm moving around. I mean, I wear it all the time. Like it tells me if I've got that 100 minutes of activity. I've got a fasting tracking application that can tell me if I've reached my goal amount of hours for the day. I've got a repo that's able to actually check if I've written for the day. So I have different data sources that are being solved in their own unique ways, but they're totally different data sets. One's a repo on GitHub. One is a CSV that I have to manually export every now and then and upload to a service that will then parse it and turn it into an API. One is a very locked down service provider, Fitbit. I love your products, but my goodness, it is such a pain in the everything to work with your API. So there's a lot of different services here at play, and I'm trying to create a unified view, a unified API, and not even just unified. I want to get benefits that are on top of that. That's kind of the task that I've got, is sort of this idea of creating these different pieces. And so the flip side of that part of the data layer is that so then graphs are essentially for exploring. So not only then do I have these connected pieces of data, I'm able to start to look at relationships between this data. What happened on the same day? Does my resting heart rate correlate to my activity? Does the amount of hours that I was fasting for the day, does that correlate to something interesting? Was the overall tone of my writing negative or positive based on how many hours I was fasting? That might be an interesting one to take a look at. So there's a lot of different pieces of data here, but this idea of exploring and playing is something that GraphQL actually opens up for us, because it's allowing us to bring these pieces of data into a unified API to look at. And when we look at this from a data layer, and I'm going to be using Hasura for all of my stuff tonight because I work there, but also, I mean, it's an open source tool as well as a cloud platform. So if you want to do the free route, totally like go for the free route. We've got a great, and on the cloud route, if you like the SaaS thing, that's great. And when you have this data layer, it's able to create like helpful protections and helpful optimizations around this layer of data, allowing me to explore around. So layers are for aggregating, they're for controlling, they're for streamlining, and graphs are for exploring, and the federation is for unifying. So how do we put this all together? What does it kind of look like at the end? So I've got this idea of a whole bunch of these different data sources I want to connect. And I've done most of it already, because there's no way that I would do all of that in 30 minutes. But let's look at the different pieces that ended up getting connected together. So we're going to start with just a quick example of the API. I'm not sure how many of you are familiar with the Hasura console. Hasura is a GraphQL generation tool. You give it any database, it'll make a GraphQL API for you instantly. We do have an open source version. It's the same thing that you would get as the cloud console. Cloud's got a few extra things like monitoring and observability and some, I mean, things that you would expect to have in a cloud platform. But you can totally use the open source version as well. There's a Docker image for it. The Hasura Cloud Console, it takes this data set and it gives me a base API. So if I go ahead and look at my data layer here, just kind of as a quick breakdown of what I'm actually working with. So these are my tables that I have. I have some tables that are created where I have the idea of a daily log. And if I look at this daily log, so this is like built into the database. This is the stuff that I said, okay, I'm not going to find another tool that tracks this. I'm going to track this on my own in a database. I have a daily log. It's checking to see, have I meditated for the day? What was the date that I logged? And then is the day completed? So fairly basic. 100 days of meditation in there also. then I have this idea of count habits. So getting into a bit more of the ethereal kind of concept around data structure. So basically, what's going on here is these track a habit type and then the total count as well. So these are countable habits. The countable habits are push-ups, sit-ups, squats, or kettlebell swings, and then the total count of what's being done there. And there's an enum that's doing a database check. I'm not going into database theory tonight, but this basically allows me to say, okay, I have all of these countable items, and then I can create a nice little view on those. For example, with push-ups, this is then a database view of the count habit table that is simply saying, hey, get me everything that is a habit type of push-up. And then I'm able to connect that as a relationship. And this is where we start to get into the GraphQL bits. Underneath the relationships tab, I'm going to go back to daily log here. We can kind of see how that's set up here. If we go to relationships, we'll see that I have an object relationship to the push-ups view, which is kind of like a virtual table that is connecting this on the date columns. And what I get out of that then is when I come to the API Explorer, and this is the GraphQL thing, so I don't have to explain GraphQL to anybody here, but this allows me to do something like daily log, and then I can do limit 1, and I'll just grab the push-ups for the day and the count. So that will probably be 0 for today because I haven't logged anything, but let's go ahead and see what we get. So no push-ups yet for today. So you guys can guess what I'm doing tonight. But we have we have push-ups. I have some of the additional data here, which is interesting. You can kind of drill down to did I meditate? So again, I have not meditated for today. But what we get is yes, I did today. So all right, that's done. But what we get then is on that table. What you didn't see there were some interesting things, kind of like fasting data. So when I go for the fasting data, what becomes fascinating here, and I probably have a failure in my REST API because I have 0 data on today. It's okay. What I get on the fasting behavior here, like I haven't logged that anywhere, right? I haven't actually added that to my tables. This is a federated data source. This is actually coming from a remote schema that is allowing me to merge this content into my API. And that's coming from this one here specifically. I called it Fitbit data before I added on the fasting information, so it's technically a little more. But if we look at it's just a simple GraphQL endpoint that I've created as a schema. But again, we talked about that, like the Fitbit data, the CSV parsing, all of that stuff, that's not GraphQL API. So where's this API coming from, and how is that actually getting the data that I need? And when I can come in here, and I'll show just really quickly how this is connected. So I go back over to my data and back over to my my daily log here, and I go back to my relationships. We'll see that I have these remote schema relationships now. So I have this fasting data, I have this Fitbit heart data, and I have this Fitbit activity data. So looking at these different data sources, I had that fasting information. I have now, let's say, the Fitbit heart data. And using introspection, we'll see we actually get a whole lot of introspection on the Fitbit API. Like, that's really cool. Like, it's a much better way to work with the Fitbit data API. I can go into heart rate zones and drill down on there, and we'll say, okay, just go ahead and give me the amount of minutes that I was in the zone, and probably the name of the zone is helpful. And on top of that, I want to see what my resting heart rate was for the day. I have to limit this because I don't want to slam my my free application settings with Fitbit here. So we can see that we're getting like all this data back, like coming straight from the Fitbit range. This is Fitbit heart data. If I wanted to add some more data here, we'll go ahead and say Fitbit activity data. And I can get something like the summary. Let me know if you have a problem hearing me because it sounds like I triggered She Who Shall Not Be Named on my Mac. So if my audio cut out, let me know in the chat there. So on the summary there, if I want to drill down, I can go ahead and grab the activity score or whatever. I get the thumbs up, but the audio is still good there. So Apple, you kill me. All right, we're gonna go ahead and just grab the total steps there. Why not? Okay, so we're getting the data from activity here. So what we're doing here is we've got these federated data sources. We've got fasting data coming from an app in an archaic format because I'm exporting a CSV. We've got Fitbit data coming from different resolvers, resolving data behind what we need there. So like this is a really cool GraphQL API that I'm able to now read for all this data for myself. So this is kind of the story, right? This is the idea of a federated graph here, where I can get these different data sources. I'm able to see how they play. But let's talk a little bit more about what I was referring to now with this exploration or with this playing side. So who's got the time to actually go out there and write a bunch of wrappers for the Fitbit API data and all these like ridiculously crazy things, right? Because that's nobody's got the time for that. So I want to show you kind of how I built this, showing how with the tooling out there, we can really sort of start to stitch together these interesting pieces of content with actually relatively little amount of effort. So one of the big players here for the Fitbit data, and I want to just kind of show them off for a second, is Pipedream. I'm not sure if anybody here is already familiar with Pipedream. It's kind of a low-code-ish platform. So I got these workflows that I've created. I'm going to go ahead and show what we're doing here with the Fitbit activity data. And with the Fitbit activity data, I'm able to say, okay, give me a trigger event, right? And I get this random Pipedream URL. Works, like totally works. And I then am able to pass in another step here. I ran a custom Node.js thing here that's able to just check for some security pieces just to kind of make sure that nobody watching this slams my API because they're being malicious. So I just do a little check here to kind of say, hey, just error out if it's not authorized. But then I have this like Fitbit step, and I can just like connect to the Fitbit app. And so I'm offloading all of that OAuth, refresh token logic, all of that to this provider, giving him the scopes that I want to have access with, and then I have an authenticated environment. Like that's really cool. And then this is my my domain code, right? It's an async fetch request. It's just grabbing in the token from Fitbit, then is just doing a request and sending it back. Like the final response is just giving me this activity request from the activity API. That's actually really, really cool. So I'm able to see, like with one of these workflows, I can actually see that execution that's happening here as well. I can see all the things from the request. I can see what was being responded with. I can see each of the steps of what's happening, or if there's errors. I get all this introspection. It's basically like Lambda as a service here. And I'm able to take this this endpoint and start to work with this. So now I have an endpoint that takes, if you look at the actual parameters it's checking for, it's looking for this idea of a body input date. And where am I going to start to stitch this into my system? Well, so where I stitch this into my system is I actually stitch this in starting off with a inside of Hasura itself. So I go back to Hasura here, and under these actions are an ability for me to take REST endpoints and create executable actions with them. So I have this idea of the Fitbit. We'll go with the activity data here. And what I do is I define on the query type. I go ahead and I define this Fitbit activity data is taking in a date format of a string, because that's what I'm working with. And the return type is this activity return type. And it gives me activities, which is a JSON thing, goals, which is a JSON thing, summary, which is a JSON thing. And it's just giving me this blob of data. Cool. So I mean, that's already somewhere. But like, we'll look at the heart rate data, because we kind of looked at that a bit more, or JSON-B if you wanted to. So I'm going to go back to the activity data, because that's fine. So we saw on the activities, though, that I was getting introspection on all that data. I was able to drill down. I was able to see all the individual pieces. So JSON, not exactly schema friendly when it comes to introspection. So what's happening here? Something else is being done with this data. So I've got the resolver here. I'm telling it what kind of a type it's looking for on return. And even if I were to introspect against this on this Fitbit activity data request, let's go to the API to see what we're getting with that one specific request here. I'm going to remove that for the moment. If I just run a query here for this request here, the Fitbit activity data, and I pass in the date, and I'm going to do something like a 2021 of a 10/03, but then I'm just like looking to see what it returns. Okay, there's activities, and I'm able to get like some content back, but like it's not all of the data that I was expecting, because the JSON response type is schemaless. So what do we do with that? So we've got these offloaded service workers that are fetching our data for us when doing the authentication, and they're resolving the data. We got a resolver as a service executing over a pipe dream. We've got this ability to persist those queries and those actions here inside of the Hasura console, which now makes this an executable environment for me. But again, I want this to actually be something that I'm able to introspect, get all the data with. And when I come now inside of this is where the stitch is, I can now take those this API, and I'm going to create a wrapper for those REST requests that give me then the full typings. But now I have a bit of a problem here, right? So this is something that Hasura is going to fix here soon. In an ideal world, I'll just create a relationship between those actions and my table. I pass in the request, it returns back the response, and I would be able to give in a bunch of nested Scholar types and get like a full relationship. That's like actually the end goal that Hasura is going to go towards, and so that's going to like be there. We're going to have all that data, and that's fine. I'm not there yet. So how do I create this system in a way that is going to scale and be able to stay evergreen with me as I start to build out my system? So I have the idea. I've already got the resolver, and I've got that as an action. And at some point, that's actually the final step for me. But until then, what I've done is I could create a Apollo server, which just takes all of these different endpoints and is able to give me an API with the typings. That's one way. But then I have all these random API endpoints that I really don't want to be maintaining because they're all totally different. And it's difficult for me to maintain permission control and access control and everything else. So the way that I can solve that here in Hasura again is if I go to what's this REST option here, I'm able to actually take something like that activity data. I'm able to execute that action as a REST endpoint that's now parameterized the URL, but I get a consistent API naming schema now. So I can actually get predictable API path names for these actions that are resolving. So I'm essentially creating a proxy for my actions that give me a consistent naming system. With this now, and with this single unified fact that I know how to actually authenticate against this endpoint, now I can go into something like the Apollo service here. And when I create, for example, my REST data source, I'm able to create a single base endpoint. I'm able to pass in the paths. I'm able to create a nice little SDK for myself using the authentication endpoints and patterns that I have with Hasura, and these essentially fronting REST APIs for those actions that are actually resolving a pipe dream. Now, so if you're tracking, it's pipe dream to action to REST to Apollo, and then as the Apollo schema back into Hasura as a remote schema. It does start to get a little bit batty. And this is where we're talking about the fun part and the playing around part. But what's interesting then is what we're able to do is we can take those, because we had the issue that our endpoints are giving back REST data and the actions are returning back basically JSON blobs. What we can do when we pass all that into an endpoint inside of Hasura, we're able to actually get the typings from that. So from here, and you can use kind of cool utilities such as this JSON to GraphQL typing. You paste in a big JSON blob, and it gives you the data you need. I think I have some in my pasteboard here. Here's some sleep data, so you could actually just quickly generate typings, copy those over, and paste them in. You can get all these strong typings for these GraphQL endpoints now that otherwise you would have had essentially JSON blobs, or you would have not had this sort of typing. So using these typings plus this mapping to the API endpoints, we're actually able to get all of that benefit of GraphQL now brought back and created as relationships, where I have a smooth upgrade path in the future once the features start to become maybe potentially a little bit more rounded out, or something gets added, and I can tweak that, and I'm able to update and adjust each of these endpoints here on their own, all within my Hasura platform. And what becomes particularly really nice is then if I come back to this API page, now this is all inside of my data layer. So I know I'm kind of giving a really fast dump of this architecture. But so here's where it kind of all comes together. So what we've done is sort of this playground. We have offloaded resolvers that are handling the tricky bits of auth and everything else with external services that we wanted to bring in. We get that into a REST resolver that gives us the data. That data we're able to bring into Hasura to bring it in part of an initial API that I can then map to a REST resolver inside of Hasura. That gives me a consistent interface for all of my REST resolvers for all of my data sources, from naming to authentication. When I bring that data now over into my Apollo system, I get the typings to bring it back as a remote schema to be able to actually introspect all of those details as deep as I want to go. This is like really getting to be the kind of magic part. And now, because all of this is connected inside of the Hasura platform, and as the data layer, I can get a couple of beneficial things here, and I'll just kind of do a little last 2 minutes here. If I come in here and I show, for example, this query we have. So for those that are watching and are astute, you're going to see this thing took kind of a few minutes or a couple of seconds here to execute. So I mean, and it's rightfully so. I'm using free tiers. It's going like multiple requests to Fitbit. It's catching other data. So like a bunch of random resolvers here, kind of doing round trips. It's slow, and there's reasons for it. Now, what's cool though about it being a data platform, if I come in now and I say something kind of like, we're going to call this the get 2 days, give it a name here, and because I'm on a data layer, I pass in something helpful like maybe a cache directive. Give this a little bit of time to live on it. I'm going to go ahead and cache the first response here. You'll see that it still takes a second to come back. But as soon as it does come back then, and I run that again, we get a much faster response time. And again, using the data layer services, we can come in here and actually look at something like this monitoring tab. This is cloud. You do have access to this on the free tier. But if I come into the operations here, we'll see that without having to do anything beyond simply adding the @cache directive, I actually get a lot of performance gains. So I'm on some edgy networks here. So I'm going to have to see if I have to reload this page here. Let me give it a second. I tried updating my home network today. We'll see if it's fighting me. Give it a second here. But we'll see when we get the console load here, we're going to see what the actual cache performance did for that execution time. So let me see if I get to the overview here. And I'm just at time here. I've been told to take my time, so I'm not going to rush. Okay, so while it's loading the content here, what's interesting now, because we have the remote schemas, you actually can see now a really nice overview of the entire system as well, right? So I've got this remote schema, Fitbit data. We have these 3 actions here that I've already enabled, and I can see sort of this healthy status of these different tools. If I go to the operations tab, and I am wondering why it's not loading snappier for me at the moment. I had to get an LTE box because I've got very terrible internet through the copper making its way to my house. What I'm going to do is I'm going to cheat a little bit. So while I'm letting that run, I'm going to go ahead and go back to the API here and just show again some of what we can do. So I come into the, did it just snap over? No, it didn't. Let's go ahead and just show off a little bit how we could actually add some additional data here. So if we go to the daily log, I'm going to go ahead and add a relationship on that while it's thinking about what it wants to do. Let me tell if it gives a bit of a wider range, maybe. I'm going to just check to see if there's any issues that are maybe actually downage. So I'm guessing that I have no idea. Maybe the bug that haunted Facebook the last couple of days. Maybe it's DNS, right? What was the meme that was going around? It's not DNS. It can't be DNS. It's always DNS. So I'm going to have to probably. Well, the thing is, this is the part of DevRel for those that everybody knows. You build up to this moment to show, and this is what you get. So. What we saw, I'm going to go ahead and run the cache again because the endpoint was running. So let me go ahead and run that query again that we had. So I'm going to just dump this back in there. We're going to cache this again. We call this query it to at cached PTL 300 seconds. Which is the max cache we have. All right, so we'll go ahead and run that. Takes a little bit of a few seconds to do its round trip resolving, and then as soon as we do it again, we can actually view we can actually see how fast it gets the response back. So that behavior, that ability to take all those connected data pieces and put them together. I was hoping I could show you the actual millisecond differences, because it's pretty impressive to see. But it looks like that's not going to happen tonight. Normally it's working more snappy. But when you can get those pieces connected, what you actually end up seeing then is a super fast, the benefits of getting all this data together. So it's not just about caching, it's about, getting permissions on there as well. So if I wanted to take that remote schema and I wanted to say that I want to maybe enable permissions on let's say this sort of a user role for an app that I was generating, and I wanted to actually say, okay, this is like my Fitbit data. I can go ahead and say that they're allowed to see the heart rate zones and the amount of time, but they're not able to see something else. Like, I'm extending these permissions from this Hasura platform over onto my API that's coming from all kinds of different places. That's part of the data layer, or the idea of being able to connect everything into a single place. I can do subscriptions on these different data sources and bring them all into the same place. And this is really where the power comes into, of taking a data layer as my aggregation source for REST endpoints and these other different data sources that I'm trying to play with. So I'm not going to try and I'm giving up on this console. This is typically a really fascinating place to go in there and play around. You can do things like API limits and whatnot as well. So we'll let that die in its own shame tonight. But it's a pretty fun place to check out as well. And you can get access to that on the free developer tier too. But yeah, this is the data layer concept. So my encouragement to those that are watching this, go out there, play with these different data sources, play with concepts like Pipe Dream here with the different with the different sources and things like that. Have fun, be able to explore around, and it's going to really give you the content that you need to sort of explore the next step for your development career and the things you want to build. So that's it. That's my talk.
Okay, thank you, Jesse. A little bit of a demo effect at the end, but it's
demo gods.
Yeah, if Facebook can do that I think so. Yeah, that was really great, and it was amazing to see how you can like seamlessly join different types of data sources and play around with it, really on the prototype phase or maybe even later. So amazing, Jesse, and thank you for this talk.